For our third example of a pH problem, I'm doing another acid one, but this time the acid is a couple of problems with this one. One, last time I did an acid, I had a monoprotic acid. This time I just gave you the name. You don't even know. Last time I gave you a nice easy number like 0.001. You could do that log in your head. This time I didn't. All right. So let's write the correct formula for the acid first. That's number one. Sulfuric acid, I have to know. What is it? He's H plus 1, SO4 minus 2, H2SO4, right? That's the correct formula for sulfuric acid. You should know that. That could have been a question on any, the previous 2 weeks. We've been doing acid base. By the way, we will have the test by Friday. I figured we kind of have to have it by Friday for a couple of reasons. Even though I'm out tomorrow, we are done with the material as of today. Tomorrow I won't be here. I'll just leave you a video, pressure video, and just the acid one. Acid video, yes. And then Thursday we'll review, and Friday will be the test. So it's like there's nothing, but there is a lab that the other class is going to get to do before the test, which is not a big deal because it's not on the test. It's the Tums and Rollage one. You guys will do it on Friday after the test because you have a double on Friday. Anyway, what was I saying? I forget now. So yeah, well, either way, this is the last day of new stuff, and the test is going to be on Friday. So we definitely I won't be here to help you tomorrow, so you want to pay real good attention to get this worksheet done. All right, what do I do? What do I show for work for this guy? I have to first show the equation, H2SO4 reacting with water, and by now you should know what that gives me. What that gives me is, what? H is donated to water, so I get H3O, and the SO4 is left behind, all right, with a minus 2. A little aqueous after that if you want to. I'm not really looking for that as much, but yeah. All right. That's not balanced stuff. I got a problem with this, don't I? What's that? So you still want H? I just said that's not balanced stuff. We're not done. That's why you're copying this down. You're all watching. You're all copying this down, right? I told you I'm doing this for a reason. All right. This is the third example of. This is the second one of an acid. If you look at this guy, he isn't balanced. How would I balance this guy? This H lost. This H2SO4 lost 2 H's, didn't he? He lost 2 H's, right? Can you balance this? Well, there's one sulfate. He's okay. But there are how many H's here? 4. Yeah. What am I going to need? What am I going to need to do to balance this? What do you use your head to figure this out? 2. I would need 2 waters and 2 H3Os. And that makes complete sense if you just think about it. If there are 2 waters, one of the H's went to one water, and the other H went to the other water, right? And you've got 2 H3Os. Got it? Okay, but it doesn't really matter. You don't have to understand. You just balance it like we've always balanced equations. Okay? But that makes a big difference. Now watch, especially if you weren't here. That makes a big difference because we learned yesterday that this is a strong acid, and 100% of this stuff breaks up. But if I'm given 0.0132 molar of this, remember stoichiometry. That coefficient means something. I get twice as many hydronium ions, 2 times 0.0132 molars, and 0.0132 molar. So I get that much times 2 for this guy, right? So when I go to do my problem, my hydronium ion concentration is actually 0.0264 molar. Okay, that's my hydronium ion concentration. Now it's pretty easy. What do I do to get the pH? Negative log of the hydronium. And again, for those of you who weren't here, this is what you're doing. Okay, because you're all taking this worksheet anyway. There's your equation. pH is a negative log of the hydronium. What does log mean? The power of 10, right? Power of 10 raised. If this were a nice easy number like 0.001, I'd say, yeah, the pH is 3. But it's not. So I have to use my calculator. So get your calculator out. It's the negative log of 0.0264 molar. What's my pH? You have to have a calculator to do this. It's going to be somewhere around, all right, this would be 2.64 times 10 to the negative second. So it's going to be somewhere around 2, but not exactly 2. What is it, Patrick?
1.58.
1.58. Now, does it make sense that an acid would be 1.58? Absolutely. And that's how you do this. And this is the amount of work you would need to show. You all go with that, right? All right. Real quickly, I'm not going to have you copy this one down, but I'll show you the slight difference between this because I do have another one I want to do backwards in a second. But for anybody who wasn't here still, maybe it was a little confused. What if this had said NaOH? Don't copy this one. I don't want to have to spend time doing it all, but let me just show you. Your equation would have been different. A base does not react with water. I don't put plus water down. I just break him up in water into sodium ions, aqueous, and hydroxide ions, aqueous. Okay? And since this guy's just NaOH, 0.0132 molar of that gives you 0.0132 molar of that, 0.0132 molar of this. I don't have to multiply it by 2 or 3 or whatever. But I would if this had said like a 3 there or something, right? I would have had to multiply it by 3. But you're not copying this one down. I'm doing this one really quick. This is an example. How would this be different? You would have had to use this. Kw equals hydronium times hydroxide, right? To solve for what? Because all I have is the hydroxide, right? I would have had to solve for the hydronium. So it would have been hydronium equals Kw over the hydroxide, which would be, Kw was 1 times 10 to the negative 14. And assume that 1 is an exact number, okay? Over, so it doesn't limit your significant figures, 0.0132 more. Okay, you would do that, you would get your hydronium, and that's what you would plug into your pH problem. Okay. Now, the last thing I have to do for you is one backwards. I do want you to copy this one down. This is just a little review of what we did yesterday. Now, this is the last one to copy down, and then you'll be on your own in this worksheet. Working backwards, I give you the pH, and I want the molarity. What do I do? Well, it requires a little bit of simple algebra. But the algebra isn't quite as simple as you might think because I have logs involved with it. So you're going to have to do something on your calculator backwards. But your all you have to have is a second function or an inverse function on your calculator, and you'll probably be able to do this pretty easily. Watch. After all, if I know the pH and I know the equation, this is the equation, correct? Everybody agrees the equation for pH is negative log of the hydronium. We, this time, have the pH. We want, this is my x, this is my unknown. So what will I do to both sides? Let's just take it one step at a time. First thing I would want to do, take the negative of both sides. If I take the negative of both sides, I'll get negative pH equals the log of the hydronium. Now, what do I have to do? I have to take the inverse log, divide by log, basically, right? So I take the inverse log of the negative pH is going to equal the hydronium ion concentration. How do you do an inverse log? Well, on your calculator, just find the second, however you were doing the log, you just find the second or the inverse function and do that with it. It probably says 10 to the something power, right? Yeah, 10 to the x power, 10 to the y, whatever it calls it. Okay? So, don't forget to plug in the negative. What this comes out to be is the inverse log of negative 4.17 equals the hydronium. What do you get for the hydronium? See if you get it right. 6.76 times 10 to the negative fifth? Oh, okay. Times 10 to the negative fifth. Okay. 6.76. Everybody else get that? Times 10 to the negative fifth. Y'all got that? Okay. I thought you were going to say 10 negative. Because it's going to be somewhere around negative 5 if the pH was 4 point something. Okay. All right. That's it.